Hey guys, Mr. Yaisley here. So we're on to lesson number 8 in chapter F about fractions. And lesson number 8 on your page is all about how to subtract fractions. So these processes are really similar to what we did for adding fractions, only we're going to be subtracting the numbers instead of adding them. So first we'll talk about if the denominators are the same. So if they both have the same number in the denominator, first we want to make sure that we've converted mixed numbers to improper fractions. So that's always, again, going to be our first step. Keeps things simple. All right. But if they've got the same denominators, we're going to subtract the numerators. Then we're going to keep the denominators the same. And then we're going to check if we need to reduce the final fraction that we ended up with. So that process is relatively the same as adding. Again, we're only just subtracting the numbers instead of adding them on the numerator. So let's talk about example A. I've got 15 over 8 minus 3 over 8, or 15 eighths minus 3 eighths. So first thing I noticed, denominators are the same. I don't have any mixed numbers, so step 1, I don't need to do any converting to improper fractions. Second thing, I need to subtract the numerators. So I'm going to subtract 15 minus 3, just like I normally would. Well, 15 minus 3 is 12. And then that's going to be over. Keep the denominators the same. Both denominators were 8 already, so it's going to stay as 8. Right? Then we need to check if we need to reduce the final fraction. Well, I know that 12 and 8 have a common factor of 4, so I'm going to divide them both by 4. So if I divide by 4 and divide by 4, 12 divided by 4 is 3, right? And 8 divided by 4 is 2. So our final answer on this one in simplified form is 3 over 2, or also known as 3 halves. So if you got to 12 over 8, you're almost there, all right? You just need to make sure that you reduce the fraction as well. All right, so let's try example B. So first things, do I have same denominators? Yes, I do, all right? Do I have any mixed numbers? No, I don't. So I can go on to the second step, which is subtract the numerators. So 3 minus 1. Well, 3 minus 1 is 2. And then we're going to keep the denominators the same since they were the same to begin with. So the denominator is 4. And then last step, let's see if we can reduce this. Well, I know that 2 and 4 have a common factor of 2. So I'm going to divide both by 2. 2 divided by 2 is 1. And 4 divided by 2 is 2. So final answer is 1 half. 1 half. So relatively simple if we have the same denominators, all right? So if you flip your page over in your notes, we're going to talk about what if you have different denominators. So as I'm looking at this page, what if we have different denominators? Well, what we're going to do is really no different than what we did when we had different denominators for addition. We're going to create a common denominator. We're going to go through those checking steps to find out what that is, and all of that stuff's going to be the same. So step 1, if we've got any mixed numbers, let's convert them to improper fractions. Just a little bit easier to work with, less chance for error. All right? Then we're going to find the least common denominator. I think on the last one I accidentally said largest first, but what we want is the least common denominator, also abbreviated as LCD. You'll see that at different times. All right. Once we're doing that, some things we need to keep in mind is this is the smallest number. So this is the smallest number that both denominators can multiply to so that they can become. All right. Now sometimes we can have a little cheat code is if we check first to see if the smaller denominator goes evenly into the bigger denominator. If that happens, then that means the one with the bigger denominator, we don't have to change it at all, and we only have to change the one with the smaller denominator. If the smaller denominator does not go into the bigger denominator, then that means we're going to have to change both fractions. So there's a number out there that they both can multiply to. Right, well, once we've done that, all right, we've figured out what that is, we've figured out what the least common denominator is, we need to figure out what did we multiply by to get those denominators the same. So once we figured that out, we're going to multiply the top and bottom of the fraction by the same number. But remember, that number is not going to be the same for both fractions. So if it was the same for both fractions, that would mean we already had the same denominator. So if I multiply the first fraction in the subtraction problem by 3, I multiply the denominator by 3, I also have to multiply the numerator, the top number, by 3. I may have to multiply the second fraction by 4, and so I've got to multiply the denominator of that by 4 and the numerator of that by 4. So it's never going to be the same number for both fractions, but it's going to be the same number for the top and bottom of a single fraction. And again, just a reminder, you must do this to each fraction individually, which is what I'm talking about. Well, once we've created the same denominators, we've created those equivalent fractions, so we've altered the numerator as well, we're then going to subtract the numerators. We're then going to keep the denominators the same. And then we're going to check if we need to reduce that final fraction. All right. Well, we've got 2 examples here that we're going to take a look at and make sure that we've got correct. So let's do that right now. So example A says 5 over 6 minus 4 over 9. Or you might also read that as 5/6 minus 4/9. Well, I see that the denominators are not the same. All right, so I already know that I'm going to have to eventually change for least common denominator. First, I want to check, do I have any mixed numbers? No, I don't, so no converting to improper fractions. So now we need to figure out what that least common denominator is. Well, first thing I always check is, does the smaller denominator go evenly into the bigger denominator? So 6, does that go evenly into 9? No, it doesn't. So that tells me that I need to change both of my fractions. So now, in order to figure out what number they have in common, I'm just going to list out some factors of 6, and then I'll list out some factors of 9. Or not factors, but multiples of them. So first one, I've got 6, then 12, then 18, then 24, then 30, then 36. I always usually do about 6 factors. And then I'm going to list out factors of 9. So I've got 9, 18, 24, or no, excuse me, not 24, sorry, 27, 36. All right, so what is the smallest number that I see on both lists? Well, if I look closely, I see that there's an 18 on both lists, because 6 isn't on both lists, 12 is not on both lists, but 18 is. Now, you may have noticed that 36 is on both lists as well, because that is also a number we could use. But what we know about that is if we use a bigger number than the smallest number possible, we're going to have to definitely do some reducing at the end. So we always want to find the smallest number they both can become. All right, so I know that my denominators are going to become 18. So what did I multiply 6 by to get to 18? Well, if I count my multiples, 1, 2, 3. So I multiplied this by 3, which means I also have to multiply the top by 3. Well, then what did I multiply 9 by to get to 18? Well, if I count my multiples, 1, 2. So I multiplied the bottom by 2 of this fraction, so that means I have to multiply the top by 2 in this fraction. So now I'm going to write my new problem. So I know that the denominators are 18, so I can go ahead and get there. All right. Well, what is 3 times 5? That is 15. And then what is 2 times 4? That is 8. So I've got 15 over 18 minus 8 over 18. So now I've got the same denominator, so I can now do my subtraction. So now I'm going to subtract the numerators. So 15 minus 8, that is 7. And then the denominator stays the same. So now I need to check, can I reduce this final fraction? Well, the numerator only has factors of 1 and 7 is not a factor of 18, so that means 7 over 18, or 7/18, is my simplified final fraction. All right, well, I'd encourage you, if you feel pretty good about it, try example B on your own, then you check your answer with mine. All right, well, I've got 2.5 minus 1 3/4. Well, when I look at this, first thing I notice, hey, mixed numbers. So let's get them to improper fractions first. So follow that step, denominator times the whole number, so 2 times 2, that is 4. Then add it to the numerator, which is 1, so I've got 5. 4 plus 1 is 5, over, denominator stays the same, 2. Subtraction symbol. Then I got to do my other one. 4 times 1, denominator times the whole number. 4 times 1 is 4. Then add it to the numerator. 4 plus 3 is 7. And then that is all over 4. Well, now I've got my improper fractions. It's a little simpler to work with. So now I need to find a least common denominator. So again, I always start with the smallest denominator and see, does it go evenly into the bigger one? Well, 2 does go evenly into 4. So that means that this 7/4 is not going to change. So I'm going to just go ahead and bring it down. Minus 7 over 4. Make sure we can see that. Yep, we're running out of room there. There we go. All right, but I need to change this. Well, what do I multiply 2 by to get to 4? Well, I multiply that by 2, which means I also have to multiply the top by 2. So my denominator is 4. 2 times 5 is 10, so my numerator is 10. And so now I've got denominators that are the same, so I can do my subtraction. So subtract the numerators. 10 minus 7 is 3. And then the denominator stays the same, so I've got 3 over 4. Then I need to see, do they have a factor in common greater than 1, and reduce if they do. They're only 1 apart, so no, they don't. So 3 over 4 is my simplified answer and final